I'm going to graph a sine function that has several transformations included in it. And I'm going to graph f equals 1 plus 2 times sine of x. When I graph, a few things I like to do. I have a grid, first of all, already prepared and set up for me, which is great. And I'm looking at the scale on the axes. They go by pi over 2 increments. I'm acknowledging there is a tick mark in between in the middle. We are going to graph this on the interval of 0 to 2 pi. I always like to acknowledge what the period of my function that I'm getting ready to sketch is, so that I recognize how many cycles I can sketch on one grid. Now, I look at this and I see that the c, which is the coefficient to x, is 1. Okay, and so I know that to find the period of any sine or cosine graph, it is always ran by this formula, 2 pi divided by c. And since c is 1, then I know that my period is 2 pi, which is good. That's the standard period of any sine or cosine function. So when I create my table of values, I'm pretty much want to break this up into 4 parts, if you will. So I always start, and I always suggest to start at 0 radians for your x values, which is your input values, and end it at whatever the period is. And you're going to pretty much find a total of 5 points. Get yourself 5 points to plot on your graph to fulfill one full period. That's why I'm breaking it up into 4 parts. So what I'm going to do is first find the angle that is directly in the middle, or the midpoint of 0 and 2 pi, and that's easy. If I look at this graph here on my x-axis, it pretty much tells me what that angle is. If I just look in the middle directly between 0 and 2 pi, it's pi. Put that in the middle. I'm going to do that again, kind of look for the angle directly in the middle of 0 and pi, which is pi over 2. And then one more time between pi and 2 pi, the angle directly in the middle of that. That's 3 pi over 2. Okay. So now here's where we are. We now have our angles for x, our input values that we're going to input into the function, and we're going to evaluate this. So here's how that works. First, you're going to find the sine of the angle. You're going to multiply it by 2 and then add 1 last. It's the order of operation you'll perform. Now, to figure out the sine of the angle, you want to use your unit circle. I always tell my students, you learn the unit circle by taking a blank one and you fill in the values of the angles in radians and degrees, then you find the coordinates in each quadrant. And that's the best way to learn the unit circle, not through memorization. Memorization is temporary. You don't learn it by memorizing it. When I say you memorize it, you learn it on Wednesday, you forgot it by Saturday. You don't want to do that, especially with trigonometry and the values of the unit circle, which is really the foundation of all the work that you're pretty much going to do in trigonometry. I'm going to continue to set these up. So you can see how we're going to solve this. Okay, so now you're going to do some evaluating along with some mental math. I'm not going to pick up my calculator to do this. I'm going to do it in my head because I can, and you can too. The sine of 0 is 0. 2 times 0 is 0. 0 plus 1 is 1. So your first value at 0 is 1. Next, the sine of pi over 2 is 1. 1 times 2 is 2. 2 plus 1 is 3. That's your next value. The sine of pi is 0 times 2 is 0 plus 1 is 1. Again. The sine of 3 pi over 2 is negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. Finally, the sine of 2 pi is 0. 0 times 2 is 0. 0 plus 1 is 1. And there you have your values. Now, what I'd like to do is kind of look at what this question below is kind of here asking, what key features change from the original sine graph with no transformations to this one. And I noticed two things that changed. I noticed that my amplitude changed because I have an a value, and I notice I am adding a constant to my function, which represents the midline. So what I always tell my students is you should always draw your midline on your graph. Okay, it's very important that that's on the graph. So you draw your midline at y equals 1. Hopefully you'll draw your line a little bit better than mine. But nonetheless, there it is. I'm going to plot my points, my 5 points. I'm going to, what I consider not necessarily cheating, but I'm just going to make my points pretty definitive so that you, the viewer of my video, can see them clearly, know where they are in comparison to where the midline is. So the first point we plot was at 0, 1, then pi over 2, 3, and then pi 1, and then we're going below to 3 pi over 2, negative 1, and we're going back to 2 pi at 1. There we go. You have a sine graph. And you can kind of see, looking at the graph, these characteristics. Clearly your midline at y equals 1. You have an amplitude or a distance of 2 from the midline to the maximum point, midline to the minimum point. It's a distance of 2. And so there's your graph of this sine graph. And this works exactly the same for a cosine graph as well. If it were a cosine, it would look different, of course, in terms of its shape and the points, but the premise of how you would sketch it is the same.